Encapsulation is all about how we manage our fields and methods within a class. Our fields should be private so they're protected, and then we create public methods to work with or provide access to those fields. C# does have another option for encapsulating data. It's called properties. Properties are kind of a cross between fields and methods. They give us the ability to write code to control how the fields are used, but in our driver class, they can be treated as if they were public fields, which makes them a little easier to work with. It's important that you know how encapsulation works using just fields, getters, and setters, but in practical terms, I think most C# coders use properties most of the time. With that in mind, we're going to modify our mobile customer class to use properties. I'm starting with the code from the end of the video on constructors, and as I've done in previous videos, I've renamed the files in order to keep these different versions straight. So I right-clicked on mobilecustomer.cs and changed it to mobilecustomerproperties.cs. If your IDE changes the class name and references to match, that's fine. But in this case, I just left my class name as mobile customer. And then I'm also going to add the word properties onto the file name for mobile customer demo so that it's mobilecustomerdemoproperties.cs. The GitHub repository linked in the description has copies of these files if you prefer to just download or copy my code. I'm going to start out by going down to my getters and setters and just commenting all that code out. I don't want to delete it because I might have use for it later, but if we're going to use properties, we don't really need these getters and set methods. I'm not going to do anything with our mutator methods for the time being. We might come back to those at the end. And I'll move back up to the top of the file here. The conventional place to put properties is right underneath the fields and before the constructors because they really are kind of like fields. So I'll add some space there to give me some room. And I'll start by creating a property that I'm going to associate with my name field. So the whole point of these is for them to be accessible. I'm going to need to make this public, and it's still a string. And it's going to be called name, but I'm going to put a capital N at the beginning. I'm going to use what we would call Pascal case for these properties, largely to distinguish it from the field name. The convention in C# is that a field gets a lowercase letter at the start, and a property, like a method, gets a capital letter. And out of habit, I put a semicolon at the end of this, but for a property, we have to have the ability to have blocks of code. So this is actually going to need to have some curly braces here to give me a code block. Within this property, we're going to have two kinds of access that we provide. We're going to have a get accessor and a set accessor, just like we would expect from our getter and setter methods. In the case of properties, all I need to do is say get and then provide a code block. And that code block is going to be the code that is used whenever we use this property in a get-like fashion. In other words, whenever we want to find out the value of the field that's associated with it, it's going to run this code. And just like our get methods, it's really straightforward. We're just going to return this .name. If I move over to my demo class here, my demo program, I can see that I have a whole bunch of errors because I commented out all of those get and set methods. In order to be able to run this code, I'm going to comment out most of this code that has errors now. But I'm going to keep this first one where we're getting the name. The idea now is that I have a property to do that instead of having to use a method. If I just use name with a capital N, and I don't put parentheses on the end because it's not a method, this is a property, that should work. So let's run that and see what we get. I'm expecting it to just print out the name of the customer. And there it is, Deadpool. If I try and use that property in a way that changes the value, so if I say customer1.name equals Spider-Man, I get an error because property, I'm reading the error here, Property or indexer mobile customer dot name cannot be assigned to. It is read only. Let's go back and take a look at the property we wrote. I provided get access, but I didn't provide set access. So already we've got a good look at how we can encapsulate here. If I have something that I want another class to be able to access and get a value from, I can just provide a get accessor. But if I want to be able to change that, or if I want to allow them to change that outside of the class, I can provide another block of code for a set accessor. This again is going to work really similarly to a set method. I'm going to say this.name equals, but now I've got a problem. I don't have a parameter to set, right? I didn't ask for a parameter here because it's not a method. So C# has a keyword to address this, and it's value. So value in this context is whatever value the other code is trying to assign to this property. Okay, so I have this.name equals value. And if I go back over to my demo class now and take a look, that error has cleared up. And so if I print that name again, I'm going to see if it prints Deadpool and then changes to Spider-Man for the second output. And it looks good. This basic property provides unrestricted get and set access to the underlying field. In other words, the other programmer or the other class can set that name to any value they want to set it to. That's not always what we want. The whole point of encapsulation is that sometimes we want to control or validate things as they get assigned. Our phone number property would be a great example of a place where we could use some data validation to make sure they've typed in something that at least looks like a phone number. Unfortunately, that's kind of complicated and maybe beyond the level of a beginner programmer like we are. So we're going to ignore that one for now, and let's take a look at monthly data. Monthly data does have some simple validation we can do. The amount of data they get each month shouldn't be a negative number. So let's write a property for that. Public, this is going to be a double. And the name is going to be monthly data with a capital M. And my getter, my get access, is going to be the same. Return this.name. And I've written it all on one line of code. Oops, not dot name. Monthly data. I've written it all on one line of code because this is a convention you see often among C# programmers. If you're just doing a simple one-line get access code or one line of set access code, typically people will just put it all on one line to keep it compact. But our set access needs to be a little more complicated. What I want to do is check to see if the value they're trying to set is above 0. And if it is, I will let them make that change. If it's not, we will just do nothing. So that's going to be a simple if statement. If value, I'm using that same keyword for the value the code is trying to set. If value is greater than 0.0, then this dot monthly data equals value. Let's go back over to our driver program and see if we can test this monthly data property. Rather than copying and pasting the line of code I have using the getter, I'll just start from scratch here. And as long as I'm here, I will also output the same field, same property for customer 2. With a little bit of explanation. The idea here is that I can use that property just like it was a regular variable that I had access to, and I can embed it, for example, into a write line statement. Let's go ahead and run this and see how it works. Okay, 16 and 8, that looks correct. Let's test the set access. So for customer 2, monthly data, I'm going to try setting that to negative 5.4. And then I will print out again after that change. What this shows is that when I tried to set that property to an invalid number, it didn't change anything. It kept it at 8. Let's go ahead and do it one more time with a valid number and make sure that it actually does work when it's supposed to. So I'll just make that positive 5.4. And we can see that that is working, both the get access and the set access. I still have 2 properties up here that I need to create for 2 fields. And I don't know if you can see it on the recording, but Visual Studio has actually shaded these a little bit so I can tell they're a little different than the ones I've done. So let's go ahead and create properties for those. I'm going to keep them in the same order. So it went name, phone number, monthly data. I'm going to have it go name, phone number, monthly data. Again, same name as the field, but with a capital first letter. And as I mentioned, this would be a really good place for some data validation where we check to make sure that it's a real phone number, or at least the format of a real phone number, but we don't know how to do that yet. So I'm just going to make this a simple getter and a simple setter. Return this dot phone number for my get, and for my set, again, I'll use that convention of putting it all on one line to make it a little more compact. And the only one left now is remaining data. Now, if we look down at our mutators, we have 2 methods that already change the value of remaining data. We can add data on, we can reset it. Actually, we have 3. I'm just thinking about adding data. We also have use data, which will subtract data from that. So we don't really need set access. This is a case where we need to encapsulate that so people can't just come along and set their data to 5. They need to use it or add it or reset it. So back up to our properties. For this one, I'm going to say public double remaining data. And I'll give them get access, return this dot remaining data, but I'm not going to provide a set access code, accessor I should say. Again, the whole idea here is encapsulation. We provide the minimum access we need to provide, and we control it as much as we can, and that's what we've done with remaining data. Let's jump back over to our driver over here, and I have now all these properties I need to test, and what I'm going to do through the magic of video editing is modify all of our old code to use properties instead of getters and setters, and I won't make you watch me type that. Okay, so I've modified all of that code, and I just changed basically the get and set references to use my properties instead. I didn't make any other changes, and let's run this and see how it works. And it looks like everything is in order. I certainly don't have any errors, and it seems to be reporting and editing the correct fields. I do have one trick to show you with properties now that we get the hang of how they work on a basic level, And that is that I can have the compiler auto-implement a property for me if I just need something with basic get and set access. And so I'm going to add a piece of data here. I want to store also this customer's email address. And I'm going to do it with a property that's auto-implemented and doesn't have a field associated with it. So I'm just going to scroll down to the bottom of my properties here. This is going to be public, and it's an email address, so that'll be a string. And I'll just call it email address. And what I'm going to do is put get semicolon and set semicolon. What this does is when the compiler gets to this part of my code, it is going to see this property and see that I need get and set access. It is going to create a field automatically for me, and it's going to write the return this dot whatever and this dot whatever equals value. It'll write all that code for me so I don't have to. And this gives us a really quick way to get started with a class if we're just trying to get going and we need some basic fields with get and set access. This will do it for us. If I want read-only access, I just put get and I don't include set. All right, for this example, we'll include set. And let's go back over and try testing this. I'll put it right at the bottom. So I'm going to say customer1 dot email address equals whatever. And now I'll try to access that and read it. Console dot. And I'll run that to see if it worked. No problem. This auto-implemented approach to having your properties and fields is really convenient, and we can use it for a lot of the projects we work on. But notice that if I don't have any code blocks for my set accessor, for example, I don't have the ability to validate anything. So in my case, personally, I often use this when I'm first writing a class and I want to get started testing it. But then as I start to develop the class more, I usually end up writing my code anyway. But I still don't have to go back and create a field to go with them. The C# compiler will manage the field for you, and it makes it a little simpler and potentially a little less confusing because you don't have to worry about the difference between the field and the property. Properties aren't necessary to create classes and objects in C#. You can use traditional private fields with public get and set methods. But properties do give us another option for how we encapsulate our objects.